Hello children, welcome to grade 6 mathematics lesson. Today we are going to talk about the third lesson, that is the mathematical operations on whole numbers. I'm Himashi Gamage from Anand Balika Vidyalaya Colombo 10. Today I'm going to teach you the lesson. By studying this lesson, you will be able to add whole numbers, subtract a whole number from a larger whole number, multiplying whole numbers, and divide a whole number by another whole number. Now I'm going to introduce you two friends. This is Sahan and there's another friend, that is Amal. Now Sahan is going to have some pigeons, so we'll count these pigeons. He has got 1, 2, 3, 4, 5 pigeons. And Amal is also going to have some pigeons. We'll count his pigeons as well. 1, 2, 3, 4. He has got 4 pigeons. So Sahan has 5 pigeons. Amal has 4 pigeons. Now altogether, how many pigeons do they have? So we are going to find that. How to find it? We'll say Sahan has got 5 pigeons. Then Amal has got 4 pigeons. So to find the total number of pigeons, what should we do? We have to add these two amounts together. So by adding two amounts together, we can find the total number of things they have. Isn't that so? So now we are going to discuss about addition of whole numbers. So we'll get an example. 5 plus 4. So previously we had 5 pigeons with Sahan and 4 pigeons with Amal. So we wanted to find the total number of pigeons. I told you that we have to add two amounts together. So 5 plus 4 is 9. Therefore, both of them had 9 pigeons. Right, we'll go for another example. 14 plus 11. Right, now there are two places in 14, ones place and tens place. When we consider about 11 also, there are two places, ones place and tens place. Can you see all the ones places are lined together and all the tens places are also lined together? Isn't that so? So you have to add the ones place of the first number with the ones place of the second number. Then tens place of the first number with the tens place of the second number. So we'll add 4 plus 1 is equals to 5. So we can write 5 under the ones place. Then 1 plus 1 equals 2. So we can write 2 under the tens place. Right. Now we know how to add numbers with two places. That means ones place and the tens place. So we'll go for another example. 18 plus 36. Right. Once again, the ones places are written together, tens places are written together. So we'll start with the ones place. 18 plus 36. So when we start with ones place, that is 8 plus 6. We know that 8 plus 6 is 14. So there are two digits. So how to mention it here? There's a question. So I'm going to get a help from somebody. We'll see. We'll learn how to find that. Can you remember this object? Yes, it's an abacus. We have already used abacus in smaller grades. Isn't that so? We have used the abacus to add and subtract values. Right, here also I'm going to do the same. I'm going to add these two values using abacus. So here I have mentioned my first number, that is 18 in this abacus. So under ones place I have mentioned 8 beads. Under tens place, I have mentioned only 1 bead. Then we'll mention the second number also in an abacus. So under ones place, I have mentioned 6 beads. Under tens place, I have mentioned 3 beads since the number is 36. So now we are going to add these two values together. So before that, can you remember the rule in abacus? Yes, you can have the maximum number of 9 beads in one line. You can't put more than that. So you have to keep that in mind as well. So we will add. Right. First of all, I'm going to count the number of beads in ones places. So there are two ones places in the two numbers. So we'll start adding. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. I have got 14 beads under ones place. So can I mention 14 beads under ones place? No, the rule itself says I can put only up to 9 beads. That means the maximum number of beads that I can put in one line is 9. So what should we do? We have to see whether in this number are there any groups of tens? We'll check. Yes, 14 can be built up by adding 10 and 4 together. That means one group of 10 is hidden there in 14. So I can't have groups of tens under ones place because there's a separate tens place mentioned in this abacus. So I have to give that 10 to tens place. 10 from ones place to tens place becomes only 1 in tens place. So this 14, I have separated 10 and gave it to tens place. It became 1 in tens place. So how many remains? 14 minus 10 is only 4 remains. So I'm going to mention that 4 under ones place. Right. Now already I have got a bead from ones place to tens place. So I'm going to consider about the number of beads in tens place. So first of all, I'm going to mention the bead that I have gifted from ones place. So we'll mention that. Right. Then we'll consider about the other beads that should come under tens place. So from 18, there in tens place, I had got 1 bead. So I'll mention it. In 36, under tens place, I have got 3 beads. I'll mention that as well. Right. Now I have finished adding the two numbers together. So I'm going to read what the number is. So under tens place, I have got 5 beads. Under ones place, I have got 4 beads. Therefore, the number is 54. So I can say 18 plus 36 is equals to 54. Now we'll discuss about the same example in another way. Here, I have separately mentioned the values in the tens place and values in the ones place of the two given numbers. So when I consider about 18, the value in the tens place is 10, value in the ones place is 8. And when I consider about 36, value in the tens place is 30, value in the ones place is 6. So under each and every place, I'm going to get the addition separately. Right. So we'll start with the ones place. So I have got 8 and 6 there. So I'm going to add those two values together. We know that 8 plus 6 is 14. So as I have mentioned you before, I can't write 14. That means I can't write 2 digits under ones place. Therefore, I'm going to give the bundle of tens to the tens place. So inside 14, there's only one bundle of 10. Therefore, when I give that bundle to tens place, I have got only 4 under ones place. So I'm giving the bundle of tens to the tens place. So under tens place, what are the values there? We have got 10, 30, and now we have got another 10 as the present we got from ones place. Can you remember? So we'll add these three values together. 10 plus 10 plus 30. So that is 50. So under tens place I have got 50. Under ones place I have got 4. All together the value is 54. Let's move on to another example. Here I'm going to add 73 and 56 together. In 73, 3 is in the ones place, 7 is in the tens place. In 56, 6 is in the ones place and 5 is in the tens place. Now, when you are writing the question, it's very important to write ones place in one line, tens place in another line. Then it will be easy for us to add. So first of all, we'll start with the ones place. So we have got 3 and 6 under ones place. So we have to add those two together. 3 plus 6 is 9. Therefore, we can mention 9 under ones place. Then we'll move on to the tens place. There we have got 7 and 5. So 7 plus 5 is 12. So can you put 12 under tens place? No, isn't that so? We can't have 2 digits under tens place. Therefore, we have to search whether there are any bundles of 10. Yes, 12 is made up of 10 plus 2. Therefore, we can get one bundle of 10 out of 12 and we can give that bundle to hundreds place. Therefore, only 2 remains. We have to give a bundle of 10 to hundreds place and it becomes only 1 in hundreds place. So there's only 1 under hundreds place. So we have to mention that. Therefore, 73 plus 56 is equals to 129. We'll consider about another example. This time it's 492 plus 876. Right. Now here we have got 3 places. Isn't that so? Ones place, tens place and hundreds place. So in 492, the digit in ones place is 2, digit in tens place is 9, the digit in hundreds place is 4. In 876, digit in ones place is 6, digit in tens place is 7 and digit in hundreds place is 8. So as I have mentioned you before, you have to write it correctly. Therefore, it will be easy for us to add. So we'll start with the ones place. 2 plus 6 is 8. 9 plus 7 is 16. So you can't have 16 under tens place. Therefore, you have to search whether there's a bundle of 10 inside that. Yes, there's one bundle, isn't that so? So we have to give 10 to hundreds place and only 6 is remaining under tens place. Then the bundle of 10 which is given from tens place to hundreds place become only 1 in hundreds place. So we'll add the digits under hundreds place. 1 plus 4 is 5. 5 plus 8 is 13. So once again you can't mention 13 under hundreds place. Therefore, we have to search whether there are any bundles of tens. Yes, there's one bundle. Therefore, I'll separate that bundle of 10. Therefore, only 3 remains under hundreds place. So, we'll mention 3 under hundreds place. The remaining bundle of 10 is given to thousands place and it becomes only 1 in thousands place. So under thousands place we have got only 1. So we have to mention it under the thousands place. So I can say 492 plus 876 is equals to 1368. Let's move on to another example. This time these numbers are with 4 places. So the first number is 3629. The second number is 3781. So I'm going to add these two numbers together. Since those numbers have 4 places each, first I'll mention the 4 places: ones place, tens place, hundreds place and thousands place. So I'm going to write the question properly. That means I'm going to write the digits in ones place under ones place, digits in tens place under tens place, digits in hundreds place under hundreds place, and digits in thousands place under thousands place. Then it will be easy for us to find the answer. So 3629. See, I have separated the digits and mentioned 3781. They also have separated it according to its places. Then it will be easy for us to go for the answer. Right. We'll start with the ones place. 9 plus 1. So that is 10. So can I mention 10 under ones place? No, we can't. Isn't that so? So I have to give the bundle of tens to tens place. Therefore, here I have got one bundle of tens. So I'm going to give that bundle to tens place. Therefore, nothing is going to remain under ones place. So if nothing is remains, you have to mention 0. I'm giving the bundle to tens place and it becomes only 1 in tens place. So we'll add the digits under tens place. 1 plus 2 is 3. 3 plus 8 is 11. Once again, can you mention 11 under tens place? No, we can't. We can't mention 2 digits under one place. Therefore, I have to once again check whether we are having bundles of tens there. Yes, we have got one bundle. Therefore, I'm going to give that bundle of 10 to hundreds place and only 1 remains under tens place. So, when I give a bundle of 10 to hundreds place from tens place, that becomes only 1 in hundreds place. So, we'll add the digits under hundreds place. 1 plus 6 is 7. 7 plus 7 is 14. Once again, we can't mention 14 under hundreds place. So once again, I'm going to search whether there are any bundles of tens in 14. Yes. Once again, I have got one bundle of 10 in 14. Therefore, I'm going to give that bundle to thousands place. So, only 4 remains under hundreds place. I'm giving a bundle of 10 from hundreds place to thousands place and it becomes only 1 in thousands place. So, we'll add the digits under thousands place now. 1 plus 3 is 4. 4 plus 3 is 7. We can mention 7 under thousands place. Therefore, we can go for the answer 3629 plus 3781 is equals to 7410. Now we'll consider about additive bonds. Now what are these additive bonds? That means how we can construct a number by adding two numbers together. That is how we are going to check now. So I'll start with 0. How to construct 0 by adding two numbers together? Yes, there's only one way, isn't that so? 0 plus 0 is 0. Then when it comes to 1, you can construct 1 by adding two whole numbers together as 1 plus 0 is 1. Then we'll move on to 2. Now, when it comes to 2, there are two ways of constructing 2 by adding two whole numbers together. First method is when I add 0 and 2 together, you can get the answer 2. And then when I add 1 and another one together, that means 1 plus 1, once again you can get 2. Then we'll consider about 3. When you add 0 and 3 together, you can obtain 3. At the same time, when you get 1 plus 2, once again you can obtain 3. What about 6? Yes, there are 4 ways of obtaining 6 by adding two whole numbers together. 0 plus 6 is 6, 1 plus 5 is also 6, 2 plus 4 is also 6, and 3 plus 3 is also 6. We'll get another one. 7. Now 0 plus 7 is 7. 1 plus 6 is equals to 7. 2 plus 5 is also equals to 7. 3 plus 4 is also equals to 7. Then when we consider about 8, 0 plus 8 is 8. 1 plus 7 is also 8. 2 plus 6 is also 8. 4 plus 4 is also 8. Finally, 3 plus 5 is also 8. So, now these bonds are called additive bonds. This is Pahan. He has got 8 pigeons as his pets. Now, one day, a very strange thing happened. 3 of his pigeons flew away and never came back. Now we have got a question. How many pigeons are remaining? So we are going to discuss about it under subtraction of whole numbers. Pahan had 8 pigeons and 3 of them have flew away. Therefore, I need to find the remaining number of pigeons. So how to find that? I have to subtract 3 from 8. So 8 minus 3 is 5. Therefore, I can say now Pahan has got only 5 pigeons. So we'll move on to another example. This time, I'm going to subtract 13 from 43. So once again, we'll write the question properly. 43 minus 13. Once again, you have to write ones place digits in one line, tens place digits in another line. So we'll start with ones place. 3 minus 3 is 0. 4 minus 1 is 3. Therefore, I can say 43 minus 13 is 30. So once again, I am mentioning you have to write each digit under the correct place. Let's subtract 67 from 94. So we'll write the question properly. 94 minus 67. So the digit 4 and 7 should be written under ones place and the digits 9 and 6 should be written under tens place. Right, we'll start with ones place. 4 minus 7. Can you subtract 7 from 4? No, isn't that so? Therefore, we have to get a loan from the tens place. So the tens place digit is 9. So 9 is giving 1 to 4. So 1 from tens place to ones place, in sense it becomes 10 in ones place. So 10 plus 4 is 14. 14 minus 7 is 7. Now only 8 remains in tens place. Right, then we'll move on to tens place. Now we have got only 8 there. 8 minus 6 is 2. So we can easily go for the answer. 94 minus 67 is equals to 27. We'll go for another example. Subtract 137 from 328. So once again, we'll write the question properly. 328 minus 137. So once again, we'll write the place values. Digits 8 and 7 should be written under ones place. Digits 2 and 3 should be written under tens place. Digit 3 and 1 should be written under hundreds place. Right, so we'll start with ones place. 8 minus 7. Yes, we can subtract 7 from 8. Then the answer is 1. Then we'll move on to tens place. 2 minus 3. You can't subtract 3 from 2. Therefore, once again, we have to get a loan from hundreds place. Isn't that so? So, hundreds place gives 1 to tens place. 1 from hundreds place becomes 10 in tens place. Therefore, 10 plus 2 is 12. So, 12 minus 3 is 9. Now there's only 2 in hundreds place. 2 minus 1 is equals to 1. Therefore, we can say 328 minus 137 is equals to 191. We'll move on to another example. 8162 minus 4375. So the digits 2 and 5 should lie under ones place. The digits 6 and 7 should be written under tens place. The digits 1 and 3 should be written under hundreds place. And the digits 8 and 4 should be written under thousands place. Right. We'll start with ones place digits. 2 minus 5. Can you subtract 5 from 2? No, isn't that so? Therefore, once again, we'll have to ask for a loan from tens place. Isn't that so? Therefore, tens place gives 1 to ones place. 1 from tens place becomes 10 in ones place. So, 10 plus 2 is 12. 12 minus 5 is 7. Now, in tens place, we have got only 5. Then we'll move on to tens place digits. 5 minus 7. So can you subtract 7 from 5? No. Once again, we have to ask from hundreds place. So hundreds place gives 1 to tens place. So 1 from hundreds place to tens place becomes 10. So 10 plus 5 is 15. 15 minus 7 is 8. Now in hundreds place we have got nothing, that is 0. So 0 minus 3, you can't subtract 3 from 0. Therefore we'll ask from thousands place. Thousands place gives 1 to hundreds place. 1 from thousands place becomes 10 in hundreds place. So 10 plus 0 is 10. So 10 minus 3 is 7. Now we have got only 7 in thousands place. 7 minus 4 is 3. Therefore, we can get the answer 8162 minus 4375 is equals to 3787. Next, we'll move on to multiplying whole numbers. Just have a look at this table. Now, here I have mentioned as an addition, you can say 3 plus 3 and the answer is 6. So 3 is added to another 3 and you can see 2 3's there. Therefore, you can write the same thing as a multiplication 3 multiplied by 2. Once again, the answer is 6. We'll move on to the next one. 5 plus 5 plus 5 plus 5. So the answer is 20. You can see 5 is added 4 times to itself. Therefore, you can mention it as 5 multiplied by 4. Once again, the answer is the same. Next, 9 plus 9 plus 9 plus 9 plus 9 plus 9 plus 9. 9 is added 7 times to itself. That means 7 9's are added together. Therefore, you can mention it as a multiplication 9 multiplied by 7. So, the answer is the same, that is 63. Next one, 8 plus 8 plus 8 plus 8 plus 8. So, here 5 8's are added together. Therefore, as a multiplication, you can mention 8 multiplied by 5. So, the answer is the same, that is 40. 10 plus 10 plus 10. Now, we can see 3 10's are added together. So, as a multiplication, you can mention 10 multiplied by 3 and the answer is the same, that is 30. Next, 100 plus 100 plus 100. So, 3 hundreds are added together. That means 100 multiplied by 3. So, that is equals to 300. 1000 plus 1000 plus 1000 plus 1000. So there 4 thousands are added together. So as a multiplication we can say 1000 multiplied by 4. The answer is the same, it's 4000. 10 plus 10 plus 10 plus 10 plus 10 plus 10. So 6 10's are added together. So as a multiplication you can mention 10 multiplied by 6. So the answer is the same, it's 60. 100 plus 100 plus 100 plus 100 plus 100. 5 hundreds are added together. So you can mention it as a multiplication 100 multiplied by 5. You can get the same answer as 500. So this is also multiplying whole numbers, but here you can say I have multiplied tens, thousands and hundreds in this table. Isn't that so? So we are now discussing about multiplying a whole number by 10. Have a look at this. 3 multiplied by 10. You can mention it as 3 tenths. So 3 multiplied by 10, the answer is 30. 6 multiplied by 10. So you can mention it as 6 tens. So the answer is 60. 9 multiplied by 10. So you can mention it as 9 tens. The answer is 90. 11 multiplied by 10. You can mention it as 11 tens. The answer is 110. So when a whole number is multiplied by 10, the answer can be easily obtained by putting a 0 at the right end of the number. Next, we'll consider about multiplying a whole number by 100. So 2 multiplied by 100, you can mention it as 2 hundreds. So the answer is 200. 5 multiplied by 100, you can mention it as 5 hundreds. So the answer is 500. 10 multiplied by 100, you can mention it as 10 hundreds. So the answer is 1000. So there also we can see a pattern of getting the answer using a easy method, isn't that so? So what is the method? When a whole number is multiplied by 100, the answer can be obtained by putting 2 zeros at the right end of the number. Isn't that so? Then we'll discuss about multiplying a whole number by 1000. So 1 multiplied by 1000, you can mention it as 1 thousands. The answer is 1000. 7 multiplied by 1000, you can mention it as 7 thousands. So the answer is 7000. 8 multiplied by 1000, so you can mention it as 8 thousands. So the answer is 8000. So once again, you can see a pattern of obtaining the final answer, isn't that so? When you multiplied a number by 1000, we can see an easy method of finding the final answer. So what is that easy method? When a whole number is multiplied by 1000, the answer can be obtained by putting 3 zeros at the right end of the number. Now have a look at this. 2 multiplied by 3. So I'm going to demonstrate it using some figures. I'm going to get some flowers here. Now 2 multiplied by 3 in sense, I'm going to write 2 flowers each for 3 times. So altogether, how many flowers are there? 1, 2, 3, 4, 5, 6. So I can say 2 multiplied by 3 is equals to 6. We'll get another one. 3 multiplied by 2. Now this time in one group we are going to get 3 flowers. So we have got 2 such groups. So we'll count the total number of flowers here. 1, 2, 3, 4, 5, 6. Then I can say 3 multiplied by 2 is equals to 6. So here we can understand that whether it's 2 multiplied by 3 or 3 multiplied by 2, you can obtain the same answer. Now have a look at this table. So I'm going to go through the branches. 5 multiplied by 100. So what is the answer? Yes, that is 500. Then we'll go through the next branch. 5 multiplied by 2. So can you tell me the answer quickly? Yes, that is 10. Next one. 5 multiplied by 7. Now you can easily get the answers, isn't that so? 5 multiplied by 7 is 35. Finally, 5 multiplied by 12. So you can easily get the answer as 60. Now let's move on multiplication. So have a look at this question. 32 multiplied by 15. So first of all, I want you to have an idea about 15. So in 15, 5 is in ones place. The value represented by 5 is 5. 1 is in tens place. The value represented by 1 is 10. So first of all, I'm going to multiply 32 by 5. So 32 multiplied by 5 is 160. So first I'm going to mention it here. 32 multiplied by 5 is 160. Next I'm going to multiply 32 by 10 because since we have got the number 1 there, number 1 represents the value of 10 because it's in tens place, isn't that so? So next I'm going to multiply 32 by 10. 32 multiplied by 10 is 320. So I have to mention it correctly here. 32 multiplied by 10 is 320. Next, we have to add these two values together. 0 plus 0 is 0, 6 plus 2 is 8, 1 plus 3 is 4. So, we can get the answer 32 multiplied by 15 is 480. Let's have a look at another example. 72 multiplied by 48. Once again, we'll have a look at the number 48. 8 is in ones place and the value represented by 8 is 8. 4 is in tens place, therefore the value represented by 4 is 40. So first of all, I'm going to multiply 72 by 8. 72 multiplied by 8 is 576. So I'm mentioning it here. 576 is 72 multiplied by 8. Next I'm going to multiply 72 by 40 because though we have got only digit 4 here, this digit 4 represents 40. Therefore, 72 multiplied by 40 is 2880. So, we'll mention it here, 2880. So, we'll add these two values together. 6 plus 0 is 6. 7 plus 8 is 15. So, I have written 5. 1 remains. We have to move that bundle of 10 to hundreds place. So it becomes 1 over there. 1 plus 5 is 6. 6 plus 8 is 14. I have written 4 and 10 remains. It's move on to thousands place. 10 from hundreds place to thousands place becomes 1 over there. Therefore 1 plus 2 is 3. So we can say 72 multiplied by 48 is 3456. This is Nimali. She has got 12 rambutan. So she is going to share these 12 rambutan among 4 of her friends. So how many rambutan each of them are going to get? We'll see. Each of them are going to get 3 rambutan each. Isn't that so? Therefore, here we are discussing about dividing whole numbers. Now, previously, Nimali equally distributed the rambutan among 4 of her friends. Isn't that so? So, each of them got 3 rambutan. Now, we can consider about multiplication here. 3 multiplied by 4 is 12. So Nimali had 12 rambutan. She has distributed it among 4 of her friends equally. So each of them got 3 rambutan. And we can express this using division as well. How to do that? She has got 12 rambutan. So 4 of her friends got these 12 rambutan equally. Therefore, I have divided 12 by 4 and obtained the answer 3. That means each of her friends got 3 rambutan. So if there's one more friend, this time she has to equally distribute the rambutan among 5 friends. Now what would happen? Each one can get 2 rambutan, but 2 plus 2 plus 2 plus 2 plus 2, that is only 10. So 2 rambutan are remaining. So I can say when she distribute 12 rambutan equally among 5 of her friends, 2 rambutan remains. Therefore, I can represent it using division as 12 divided by 5 equals 2 and 2 remains. Long division method. Now, I'm going to divide the same amounts once again using long division method. So, we'll move on to the first example. 12 divided by 4. In long division method, first of all, you have to take the first digit and you have to check how many 4s are there in 1. So the first digit is 1. So how many 4s are there in 1? We have got no 4s there. Then we have to consider about the first 2 digits together. That means 12. For 12, how many 4s are there? Yes, there are 3 4s in 12. So 3 multiplied by 4 is 12. So the difference is 0. Therefore, I can say 12 divided by 4 is 3. 3 is the quotient there and nothing remains. My next example, 12 divided by 5. So once again, we'll get the first digit, that is 1. How many 5s are there in 1? You don't have any 5s there in 1, isn't that so? Then we'll get the first 2 digits together. For 12, how many 5s are there? There are only 2 5s. So 2 multiplied by 5 is 10. The difference is 2. Therefore, I can say the quotient is 2 and the remainder is 2. Dividing a whole number by 10, by 100 and by 1000. So first of all, we are going to understand what does this mean. So 50 divided by 10 means how many 10s are there in 50? 400 divided by 100 means how many hundreds are there in 400? 3000 divided by 1000 means how many thousands are there in 3000? So next we'll learn how to find their answers. We know that 5 multiplied by 10 is 50. Therefore, I can say 50 divided by 10. That means how many 10s are there in 50? We have got 5. Therefore, 50 divided by 10 is equals to 5. 4 multiplied by 100 equals 400. That means in 400 we have got 4 hundreds. Isn't that so? Therefore, I can say 400 divided by 100 is equals to 4. 3 multiplied by 1000 is 3000. That means inside 3000 we have got 3 thousands. Therefore, I can say 3000 divided by 1000 is equals to 3. Now we are going to identify the pattern of obtaining the answer. So have a look at the first one. 3000 divided by 10. We know that the answer is 300. Now have a look at that. In 10 we have got 1 0. So from 3000 we can omit a 0. So you can get the answer 300. Shall we apply the same thing to the next one? 3000 divided by 100 is equals to 30. So for 100 we have got 2 zeros. So I'm omitting 2 zeros from 300. You can easily get the answer 30. 3000 divided by 1000. So for 1000 I have got 3 zeros. So I'm omitting 3 zeros from 300. So easily I can get the answer as 3. 5000 divided by 10. For 10 I have got 1 0. So from 5000 I'm going to omit a 0. So you can get the answer as 500. 5000 divided by 100. Since 100 has got 2 zeros, I'm going to omit 2 zeros from 5000. So 5000, when you omit 2 zeros, it becomes 50. So the answer is 50. So when identifying the pattern, you can easily find the answer for these questions. Now let's consider about these number bonds. Now 7000 divided by 1000. What is the answer? It is 7. Isn't that so? So 700 divided by 100, that is also equals to 7. 70 divided by 10, that is also equal to 7. Therefore, by several simplifications, you can obtain the same answer. Now we are going to describe further on the division of whole numbers. Have a look at this example. 84 divided by 6. So once again I am going to use the long division method here. So first of all we will have a look at the first digit 8. So for 8 how many 6s are there? Yes, we have got only 1 6. So 1 into 6 is 6. 8 minus 6 is 2. Now, then we have to take the next digit near the remaining number. So, the next digit is 4. We have to take it near the remaining number. Then it becomes 24. So, for 24, how many 6s are there? Yes, there are 4 6s. So, 6 multiplied by 4 is 24 and nothing remains. So, I can say 84 divided by 6 is equals to 14 and the remainder is 0. We'll consider another example. 663 divided by 13. Right. Once again, we'll have a look at the first digit, that is 6. For how many 13s are there in 6? We have got no 13s there. Therefore, we have to have a look at the first two digits together. 66. How many 13s are there in 66? We have got 5 13s there. Therefore, 5 multiplied by 13 is 65. The difference is 1. So, next we have to take the next digit near the remaining number. So, the remaining amount is 1. The next digit is 3. We have to take 3 near 1 and then it becomes 13. So, how many 13s are there in 13? That is 1. Therefore, 1 into 13 is 13. Nothing remains. So, I can say 663 divided by 13 is equals to 51. Next, 592 divided by 20. So once again we'll get the first digit, that is 5. How many 20s are there for 5? We have got no 20s in 5, isn't that so? Therefore we'll get the first two digits together. 59. In 59, how many 20s are there? There we have got two 20s. So 2 into 20 is 40. 59 minus 40 is 19. So then we have to consider about our next digit, that is 2, and you have to take next digit near the remaining amount. So the remaining amount is 19. When you get 2 near that, it becomes 192. So in 192, how many 20s are there? We have got 9 20s there. So 9 into 20 is 180. So what is the difference? 192 minus 180 is 12. Therefore, I can say the answer is 29 with 12 remaining. It's easy, isn't that so? Now let's go through this chart quickly. Now 2500 divide by 100. What is the answer? That is 25. Then we have got 2500 divided by, we don't know what the value is. It's equals to 100. So what is the value that should be there in the blank? That is divided by 25. We know that 2500 divided by 25 is 100. 2500 divided by 20. What is the value? That is 125. So 2500 divided by the value we don't know, that is equals to 500. What should be there in the blank? Yes, there should be divided by 5. So 2500 divided by 5 is 500. Now here comes the end of our lesson. Before winding up the lesson, I'm going to summarize the things that we have learned today. So first of all, we have learned how to add whole numbers together. Then we have learned how to subtract a smaller whole number from a given whole number. Then we have learned how to multiply whole numbers. Finally, we have learned how to divide a whole number by another whole number. I hope the lesson is clear for you. Please do the homework given there in your textbook after this lesson. So that's it for today. See you in another lesson. Thank you. Have a nice day.